Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. Here is an example of what you can achieve with what we have learned today. On the left here we have a bunch of barrels which have external strain applied to a wall, and on the right we have a yellow barrel which is causing an internal strain on the wooden structure. Welcome back to this Chaos tutorial series. In this episode we will be delving a little bit beyond the basics and going into some of the fields that exist in Chaos. We will be looking at two fields today, both of them being strain fields. One of them is called external and one of them is called internal. So starting off, this is our little block that we have created a geometry collection of. So if we press play, it falls down and physics affects it. We created some projectiles to damage in the last episode, but now we will instead be interacting with it using fields. To do that, we need to create a blueprint. So we'll create it of the type class field system actor. Now, this is the type of blueprint that we need to be able to generate these kind of fields in the world. We call it BP underscore external strain. Inside of this, we can close down everything else. Inside of this blueprint, we're going to be doing very simple function first. We're going to be creating a custom event first, and we'll call it detonate, just to symbolize that something has happened. And what we're going to be saying in begin play here is essentially in the beginning just detonate. Detonate, like so. And the reason we do this will become more apparent later on. So what we need to do to be able to create one of these fields is we need to use our field system components that we have in this actor, and we need to create a transient field. And by typing in add transient field, we get this function then. And this allows us to affect the world in a bunch of different ways when it comes to the chaos destruction components. In this case, we want to change the physics type to be external strain, like so, and we want to enable the field as well. Now we're almost done. We just need one more thing, because currently we don't have this field affecting anything at all, so we need to create some kind of area for it to affect. So we'll create a radial falloff, and that component we will then drag off over here, and we'll say set radial falloff. Now this allows us to affect a field or create a field that has certain properties. So for example, we can change the fall off, which determines how much damage is going to be falling off, for example, over the space of whatever this fall off is affecting. And in this case, we will be creating a sphere also. So if we type in just sphere and choose a sphere collision, you can see that we get this volume around us now. And what we will be doing is we'll be creating this, checking this sphere as sort of our point of impact or our point of affecting things. So we'll get a scaled radius from this one. The reason for that is because we might want to scale this up and down depending on what kind of a size we want to have. So we'll hook that up as our sphere radius, but we also need to have a center of origin for our effect. So we will also get an actor. Actually, it's probably called world components, world location. There we go. Like so. Hooking that up, we now have a position in the world, which is where our sphere is, and the dimensions of the sphere will be the sphere radius. It will be affecting it with a field magnitude over here, which is our damage. So let's promote this to a variable, and let's keep it at 1, which it is at the beginning. Like so. And let's also add a print string here so we see that something is happening. So external strain added. Now if we drag this into the world, like so, and let's scale it up a little bit. Let's scale it further. Now we see that it overlaps our object, which we know is a geometry collection. Pressing play now, you can see external strain added, but nothing seems to be happening over here. And that is because an external strain works in a all or nothing kind of a way. We have defined, in this case, for our geometry collection, to have a damage threshold for clustering to be from index 0, 500,000. Our external strain here is currently generating the strain of 1. If we instead were to take this value and copy it and put it into our value for the strain, or the field magnitude, which is what we're calling it, and now pressing play, you can see that it has now broken off stuff here. So essentially what it's doing is, if it has enough, and we could also just reduce this by 1, so if we, or let's reduce it by 10,000, I guess that is. So you can see that as long as it meets the threshold, it will break something. If it is below the threshold, it does not. Now you might think, well, what if you can do it multiple times? Well, okay. If we, instead of having this, we'll just do this. We'll enable input for this specific actor, and we'll do a get player controller, just so we can easily enable inputs, and then we'll say on the key of F, we will detonate. This means we can now detonate multiple times now. Each time it will print out something. So we know that we're doing 490,000 damage, and it has a 500,000 damage limit. So if we activate it once, you can see up here, strain added, nothing has happened. Click again, strain added, nothing has happened. And I can span this however much I want, because we're never surpassing the strain needed for this to break. So as long as you meet the damage criteria for it, you will break it. Now in this case we can also go back and set our field magnitude to be 500,000 again. And since we have multiple levels on this geometry collection, we have multiple thresholds. I do believe we set it up like so. We can now detonate it multiple times, so it will fracture first the first layer, and then another time for the second layer, and then continue to do that as many layers as you have set up for the geometry collection. Now let's take a closer look at internal strain. So internal strain is, unlike external strain, something that you can accumulate. So internal strain is something you can add over time so that the cracks and breakages eventually happen. And we'll demonstrate this by making a duplicate of our external strain and calling it instead internal strain. And instead of the F key, let's change the key to E or something like that. So we have a different key so we can activate them independently and hook that up to detonate. But also have the input so we can actually do something on this one. Now, what we're going to be doing here is going to be a little bit different. So, for us to be able to do damage in an accumulative way, then we need to keep track of what kind of damage we have already done. So, we can add a component which is called return results terminal, and this one will allow us to get what kind of a state the different nodes are in, so the different clusterings. And from this we will do a set terminal field. This we will be using to combine with a sort of damage field, if you will. So we can use our field magnitude to represent our sort of damage. Add that here. And we want to use that with another type of component. So going to add here, we can add a uniform scalar and dragging that one off here and then creating a set uniform scalar. We essentially create a field in which this magnitude is doing damage, and we get a uniform scalar object reference which we can then use on later on. And we can now combine these two things to say what is the field values in this one, and then we can subtract the values of our actual strain here from that. So for that we need another component. We need an operator field, and an operator field component allows us to do computations between different fields. So in this case we can say set operator field, and you can see we get a few different field operations. We have a multiply, divide, add, and subtract. And what we want to do now is we want to subtract the field which we have here, which is the current situation of the different connections for the clusters. And we want to subtract it with this uniform scalar force that represents the damage that we want to strain something with. This then hooked up, if we remove this for a bit, this result is now a field we can call in here as our field node, like so. So we want to change the print string also to say internal string, so we can see what's happening. Let's get a space in there as well. So now our field strength is going to be 500,000, which is exactly what we need to break this object. So dragging it into the world like so, and then scaling it up a bit, and scaling it up some more. That'll be fine. So now we can see that our strain here is now overlapping with our geometry collection. So going in here, I can now press E, and you can see eternal strain is being added, but nothing seems to be happening. So going back to our internal strain, and we can actually, the damage is okay, I didn't change the type. We need to change this to a internal, where are you? Internal strain, like so. Yes, so there we go. Okay. So this should be working now. If I press E, you can see breakages are happening each time I do this. And here it is, maybe that was not very clear to see, so let's do this. We'll scale this up a little bit further. So we're actually encompassing pretty much everything now. When I press just once for internal strain, you can see that we get the breakages immediately, and that's because we're meeting the limits of the threshold. If we instead change this to be exactly half, so 25, so 250,000. Now when we press the key, we need to press 2 times for the cracks to appear and the strains actually breaking things. So you can see that they actually add up with the ability when we ping or poll essentially what our conditions is, and then keep track of it and subtracting with our threshold. So with this in mind, what we can do is, for example, let's see, where's our strength? There we go. So in our field strength here, if we were to set this to 450,000, we know that if we press once with internal strain, then it will do that damage. So now it has done that damage, but nothing has cracked. But we still have our external strain sphere as well here, which is doing... Actually, let's set that to a value so we know that this is actually working. So external strain, 1, 2, 3, 4. So okay, so 50,000 now. So only by combining this, if I spam the external strain, nothing happens. But if I do internal strain once first, we have reduced the cohesiveness, the strength of the bonds between the clusters from 500,000 to only 50,000, because we did 450,000 damage, so to speak. So if I now press the key for external strain, you can see that it breaks. So these two forces can work in conjunction, and external again only works in a all or nothing kind of way, but internal strain can allow you to accumulate damage over time. There is, however, a problem with this. If we go to the map again and we move our field for internal strain to be over here, and then let's press the key a couple of times, you can see that everything is breaking, not only where the actual field is that we created, which is over here. And that is because we don't currently have any constraints when it comes to this field. This field is essentially working across the world. So let's actually fix that. To do that, we can make use of our radial falloffs like we have done before. To make this maybe organized, we can do another operator field. So we can call this operator field falloff or something, so that we know it's something else that we're computing, because we currently have a field over here and we have a field over here, and we need to combine these. So again, we need to call the sets operator field and combine these two fields together. So this one goes into our left and this one goes into our right. And the result from this is what we're actually sending into the field over here. We also want to unplug this field magnitude and make sure that it's low to field magnitude 1 here. And now essentially what we're going to be doing is we're going to be having a area which is determined by the sphere, which will be our falloff. We could also have a falloff type in addition to this if we wanted to. But essentially this will make it so that only within this sphere, using a multiply operation over here, our threshold will be doing damage. Our internal strain will be doing damage essentially. So let's give this a try and see if that works. So we go in and we press the key a bunch of times, internal strain, and we can see that it's only cracking here on the right hand side, nothing is cracking anywhere else. So it's only where we actually placed the field in the world. So that is how you can contain different fields from affecting beyond what you want them to. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.